Hi, in this video, I'll show you how to import and graph MTS data. Alright, so I'm assuming that you have the data saved to your desktop or a thumb drive. The next thing you want to do is open Microsoft Excel. You want to make sure you use the full version, not the online ones. That way you have the full functionality. And then we're going to go ahead and try to open the text files and have uh, the, the data for the different polymers. So I'll click File, and then I'll click Open. I'll click Browse, and in my case, I put all the data under my Documents folder, Polymer data, and I'm going to try to open the data for high density polyethylene. When I click on that folder, it says no matching, no items match. And that's because Excel is looking for Excel file types, but the MTS, when we exported the data, they're in a text file. So I need to tell it to go ahead and be able to see through all the different files, so all files. That way I can select the text file. And I'll click open. And next, what I need to tell Excel is just a couple commands so that it formats the data properly in Excel format. So I'll go ahead and click delimited, click next, and make sure the tab here, the checkbox for the tab is selected. And what that's going to do is going to tell Excel to scan the text file, and that anytime it sees a tab in there, that it means to start a new column. So here we go. As I kind of scroll down, we can see that we're going to have a column called Crosshair, another one load, and the other one time. So this is perfect. So I'll go ahead and click next and then finish. And there we go. There's a file information here, the test run when we took the data, and then the crosshead, the load, and the time, and all the data is in different columns. All right, so what we need to do next is we need to plot the stress strain curves. But as we can see here, the machine did not export the stress and strain signals. It just exported the crosshead and the load. So we're going to have to go ahead and calculate that. So first we'll do the strain. So I'll type here strain, and I'll say it's in inches divided by inches. Sorry, here. And then I need to put the formula for strain. Now, you remember from the class that the formula for strain is a change in length divided by the original length. And notice what we have over here. What we have here is the crosshead position. So we know for every what is this, 10 a hundredths of a second, we know where the crosshead is located, right? So we'll take the current position, which is cell A9, and we will subtract the starting position, which is for this case cell A9, and then I'll click the function F4. Again, function F4 is going to put $A, $9, which means I'm going to fix that cell, and then I'll close the parentheses, and then I'll divide by 2. And again, what I'm doing here is going to be the change in length divided by the original length. And here the original length is the gauge length of the specimen, which for our samples is 2 inches. So I'll go ahead and press enter. So that's the formula. Then I'll click the cell, and then I'll double left click on the green box at the bottom right hand corner. Double click to copy that formula all the way down, right, for all the cells that follow. And if I just randomly click on any cell and click here to see what it's doing, so it's taking the current position of the crosshead, subtracting it from the starting point, so that's going to give us the change in length, and then it's going to be dividing by 2, which is the original length of the specimen. So that's perfect there. Next, we need to plot or actually calculate the stress. So the stress here is going to have units of PSI, and the stress is just defined as the force, which is column here B, cell B9, divided by the cross-sectional area. So here you want to check the dimensions from your notebook, but roughly the specimens had a width of 1/2 inch and a thickness of 0.125 inches. So that's going to give the cross-sectional area. I press enter and it gives me a stress. Now the stress over here is negative. Why? Because the load over here is negative. Why? Well, because when the specimen was clamped and you kind of push the clamps to close the wedges to close on the specimen to get a good grip, it put an initial compressive force on the sample, but it was just a small 15 pounds there. So that's why the stresses they're negative. Nonetheless, you can see that as I copy that formula all the way down, we can see that eventually those stresses become positive, which is what we expect because we did a tensile, right? Tensile test. Next, what I want to do is go ahead and create the scatter plot with the data. So I'll select a D9 cell. Then I'll press and hold the shift button and then the right arrow keys to select the cell next to it. And I'm still holding the shift key while I press the end key and then the down arrow. And that basically selects all the stress and strain data that we have. Next, I'm going to go ahead and click insert and make sure you click scatter plot. And I'm going to say, hey, I'm going to connect with some smooth lines, the data points. And there we go. This is going to be our stress strain curve. So next, I'll just clean it up a little bit. I will right click on it and say move chart to a new sheet. And that way it shows here by itself and I can work on it a little bit better. Next, I need to add axis titles. So about the quickest way I know how to do that is just click here on quick layout and click the first one. So it adds the axis title. So then I will triple click. Here we go, triple click to highlight all of that. And I'll call this stress parenthesis PSI, right? So make sure you have axis title and the units. On the bottom over here, that signal is strain. And it has units of inches per inches, close parentheses. Next, what I'm going to do is double click here because right now we're starting at negative value. So I'll double click and I'll set my minimum here at 0. So it looks better. Almost done. So I'll just increase the font here so it looks a little bit better. Maybe 18 over here on this one. Font 18. On the axis title, maybe let's do 24. Why not? 24 on the bottom one. Next, I will correct the title. Stress strain curve for HDPE for high density polyethylene. Almost done, except here the legend is off, right? So to correct the legend here, I will right click and select data. And then the series one, I need to change the name. So I'll click edit and I'll type here HDPE, press enter, okay, okay again. And now it reads over here polyethylene, HDPE. So I'll just make it bigger. Let me make the title bigger as well, make it look nicer. There we go. Just one more thing before I go. I don't like the numbering, I guess the numbers here at the x-axis. So I'm going to go ahead and change from scientific to just a general over here. No need to include all those numbers in scientific notation. It looks a lot better. Anyways, I hope you found this one useful. See you in the next one.